having the conversation between the business, the data science teams, and the technology teams about what problems are you trying to solve? What can AI do with the data that you have? Sometimes business comes with a lot of problems that are like science fiction.
Hey everyone, my name is Henry Suryawirawan, and you're listening to the Tech Lead Journal, the show where I'll be bringing you the greatest technical leaders, practitioners, and thought leaders in the industry to discuss about their journey, ideas, and practices that we all can learn and apply to build a highly performing technical team and to make an impact in your personal work. So let's dive into our journal. Hello, all of you, my listeners out there. It's really great to be back here with another new episode for the week. My name is Henry Suryawirawan, and welcome to the Tech Lead Journal show. Before we start our episode today, I am so happy to share that this show has reached a new milestone recently. A few days ago, our Tech Lead Journal community at LinkedIn has reached 1,000 followers, and I would like to say thank you from the bottom of my heart for liking the show and being part of this community. It is my biggest mission to keep delivering great content and conversations with great technical leaders whom we all can learn from, and to continue growing this community in order to reach more people and spread the amazing knowledge from my wonderful guests so that all of us can benefit from them. You can also play a part in my mission by sharing your favorite episodes and learnings on the show's social media channels, be it on LinkedIn, Twitter, or Instagram. I'm always looking forward to hearing your feedback and interacting with your posts and comments there. And for those of you long-time listeners and have become avid fans of the show, consider becoming a patron by pledging your support at techleadjournal.dev/patron and support me towards achieving my goal, which you can find further details on that page. Our guest for today's episode is Feng-Yuan. Feng-Yuan is the co-founder and CEO of BasisAI, a Singapore-headquartered augmented intelligence software company that helps data-driven enterprises deploy AI responsibly. He has a vast experience in the tech sector, working with the Land Transport Authority Singapore to make public transport more efficient, and with GovTech pushing data initiatives for Singapore's Smart Nation projects. In this episode, I talked to Feng-Yuan all things AI and ML, about having responsible AI, building trust in AI, also including AI possibilities, challenges, and potential dangers. We began by talking about his company, BasisAI, and how they are helping enterprises to become more data-driven and to deploy AI solutions responsibly. Feng-Yuan also explained why it is important to differentiate between what is interesting and what is useful when it comes to AI trends. We also spoke at length about deepfake, the dangers that come with it, and how to detect and prevent such potential dangers when AI implementation is built with harm intention. At the end, Feng-Yuan also shares some wisdom about the importance of having effective communication and connecting with each other in the age of AI and ML. I hope that you will enjoy this great episode. Please consider helping the show in the smallest possible way by leaving me a rating and review on Apple Podcasts and other podcast apps that allow you to do so. Those ratings and reviews are one of the best ways to get this podcast to reach more listeners, and hopefully the show gets featured on the podcast platform. Let's get the episode started right after our sponsor message. Are you a startup in software development which is less than 5 years old? If yes, our sponsor at JetBrains have a 50% startup discount offer which allows startups to purchase multiple products and subscriptions for up to 10 unique licenses over a period of months. To find out more, search for JetBrains Startup Discount Offer, or you can check out the link mentioned in the show notes. Hi Feng-Yuan, welcome to the Tech Lead Journal show. It's very exciting to have you here because you are one of the top popular people in ML and AI in Singapore. So I'm really excited to talk about AI and ML today with you.
Thanks for having me, Henry. I'm really glad to be on your program. Hope we have an interesting conversation about all things AI and ML.
So you're currently working in your own startup called BasisAI. Maybe as a start, can you introduce about the company? What is BasisAI?
So BasisAI, we are a startup about 2 years old now. I'm one of the co-founders of the company and the CEO. My two co-founders also have an extensive data science and ML background. They used to work out in the Valley companies like Uber and Twitter. And in my past life, I used to lead the data science and ML team at GovTech. When Linus and Sylvanus decided to move back to the region, we decided to set up this company because we think there's a lot of potential to harness data, to use ML. I think one, to try and scale it. So we see a lot of data science teams really struggling to productionize and make their models effective. And I think that was one big challenge that we saw. The second thing is obviously there's a lot of concern over how AI and ML systems can be like black boxes. And we really wanted to help solve that problem. How do you make your ML systems a lot more robust, but a lot more trustworthy? I'm sure we'll talk a lot more about this later on. And so when we founded the company, we saw a lot of potential talent in the region, we feel. Engineering talent, data science talent, even marketing and business development. We saw a lot of opportunity. And that's why the company is headquartered in Singapore. We were fortunate to have institutional investors like Temasek and Sequoia back us up. We're about 25 strong now and a couple of interesting projects in the pipeline that we're excited to try and grow. And, there's not that many enterprise SaaS companies in the region. And so, it's lonely, but also unique. We just want to make sure we build a great data science and engineering org and solve important problems for the future. A lot of the theme is how do you really use and accelerate the use of AI, but do it in a responsible way. And I think that's our mission.
So I'm sure it's an exciting journey, especially in AI ML. It's very trending. But before we go into deep AI ML stuff, maybe for the audience here, can you share with them what's your career journey? Maybe you have some highlights or maybe you have major turning points that you want to share with us for all of us to learn.
I have a very slightly unconventional background for tech. So before I joined this startup, most of my past experience had been with the Singapore government, doing a whole variety of different things. I would say that in the early part of my career, I was doing a lot more policy-related work, but I had a background in econometrics. Part of the challenge is you never had enough data to work with back in the day, right? So I'm talking 2004, and back then you have 100 data points, you try and draw a straight line through it and then do a linear regression. So it's not very interesting to try and use all the techniques you learned from school. And that's why I like to say I kind of was a lapsed economist. But the part where data really started getting exciting was when I joined the Land Transport Authority in Singapore in 2011. And in 2011, that was when the public transport situation in Singapore was terrible. The trains were overcrowded, the bus was terrible. So what happened was I joined a team called Public Transport Quality. So I was in charge of a team of 20 people, and we were supposed to enforce and regulate the bus companies and the train companies based on their metrics and how well they were performing. They had certain SLAs around how crowded the bus is. And then you realize that transportation is fascinating from a data point of view because there's so many different ways to measure public transport performance. And I will go into some of it. So for example, when I went to the LT, we realized we have all the tap in and tap out data from the EasyLink cards in Singapore. So actually you can calculate the number of people on a bus in time and space at any point in time. But when I used to have to go and explain to the minister, he says, just tell me, Feng-Yuan, which is the most crowded bus. I wanted to tell him, sir, it's a 4 or 5 dimensional problem because there are 200 bus lines, one direction going to the city, one direction going away from the city. There's weekday, weekend, there's time of day, there is which bus stop it's crowded at. So it's not a straightforward problem to figure out where is the most crowded point in this space. So measuring crowding on buses is actually fairly complex. Then how do you measure, for example, frequency of buses? So, you and I get very frustrated when the bus is supposed to come 4 times an hour, and then all 4 buses come at the same time, and then for 15 minutes, there's no bus. Now, how do you measure this? So it turns out that there is a metric known as excess wait time, where you assume that passengers arrive at a constant speed at the bus stop, and then you estimate the expected waiting time that they would have to wait for to get the bus to arrive. And you look at what the schedule planned expected wait time is, and you look at what the actual performance of the wait time is, and you look at the difference. And the difference is the excess wait time. Now, it turns out that in order to calculate this metric, you need a lot of granular data, right? I need to know the planned schedule. I need to know the exact arrival time of the bus system. One of my projects in the LTA was with all this data we had on GPS and tap in, tap out, we found a way to calculate this excess wait time metric across the entire bus system. And then we implemented an incentive scheme for the bus company. So now I had a metric. I use big data to calculate the metric, but I can calculate the excess wait time for all 200 buses and all 4,000 bus stops. And then I can use this to say to the bus companies, you know what? If your excess wait time score is good, you get more incentives. And if your excess wait time score is bad, you get a penalty. And the outcome is you don't realize this, but all your bus companies that you take the bus now have this at the back of their mind because they know there's a metric that they're assessed against. This is a bit of a long story, but the really cool thing about transportation and data is 2011 was a time when data science was called the sexiest profession in the world. It started to become quite hot. Big data, Back then in LTA, there was no Spark. Hadoop was just emerging, but those were almost 10 years ago. But there were a lot of exciting possibilities. And when you're able to calculate the right metrics, when you've got the ability to use big data technology, distributed computing to calculate these metrics, then suddenly there's a lot of impact on the public good, on how you can incentivize and make operations more optimal. That was a pretty important part of my career because that's when I really got excited about data. And I realized that in order to make it work, I needed to bring together multidisciplinary teams. I needed the data scientists, I needed the engineers, I needed operations people, and we really needed to work together to try and see how we could harness data in a better way. It was after that stint that I went to GovTech. This was around the time when there was a big Smart Nation push. In the past, GovTech used to be called IDA, and we never used to hire engineers or data scientists. We used to outsource everything. And when you outsource everything, then you lose a lot of capability. And so it's very hard to specify what exactly you want. I started the data science team with 5 people. After 4 years, it grew to about 50. And that was a pretty proud career milestone for me because we managed to get this team to work on data science for the public good. Now, customers were all internal government agencies, but we also obviously started not just doing analysis, but building software, building platforms, real time. This is for the government agencies as well. So that was also a pretty exciting period for me in that journey. And it was during that time that I started reaching out to diaspora from Southeast Asia, from Singapore, from the region, who were working in the US at the Silicon Valley companies and saying, hey, what are you guys doing? How are you guys doing it? Are we in the Singapore government doing things the right way? And that's how I met my current co-founders. I tried to hire them to join the government. They were like, no way in hell that's going to happen. But we kind of like what they're doing. And why did you join us? So that's my story. I'm just the sales guy, the top level in the team. But I think it requires many different types of skills to make technology effective. That's what really motivates me. And a lot of the data problems are really cool for me.
Yeah, it's interesting that you try to poach them, but you are being poached out.
Yeah, that's how it works.
So maybe can you share with us some of your biggest project in GovTech? Is it like data.gov or any other platforms that you built that are interesting?
Yeah, there were a whole range of different things. A couple of the things that we were working with was the Smart Nation Sensor platform and the Smart Nation Video Analytics platform. So these are central platforms that are pulling together lots of IoT and sensor data and helping government agencies plan better using geospatial data to plan better, to run operations in a better way. There was other things that we were working on. There was one, which I think is public information now, where we're helping the police force to basically do better case investigations and searches. So this is data that they already have in internal systems. The combination of using Elasticsearch better together with some graph algorithms to link information together whereas in the past, they had a couple of siloed systems that couldn't talk to each other and there was manual effort to pull everything together. We get very excited by using simple, well-known technology, but used in applications where it just saves the officers a lot of time. So a lot of the officers were working overtime in order to try and crack these cases, and we were just able to improve the user experience, taking the time that they would take to solve a case or to investigate a case from like 40 minutes, trawling through all the information, to basically like 15 minutes to piece all the information together. I think there were a lot of internal systems. Data.gov was very exciting because we were really on a mission to help with better information transparency and open data, which I feel is really important. There were some ad hoc cases. There was one case, I think in 2013, 2014, when the circle line broke down for a while. And for about 6 months, they couldn't figure out what the cause was. This is more my team rather than me getting personally involved. But the team of data scientists were called in. They analyzed the data. And in about half a day, they were able to pinpoint the cause of the fault to a single train. This was actually not a big data analysis. It was pretty small data, but it was creative use of visualization and different ways of data-driven thinking that basically allowed for a data-driven approach to help isolate a problem that a technical team for 6 months couldn't figure out. Rather than trying to understand the mechanical engineering and electrical engineering aspects of the system, using a more data-driven variable, we find some hints to what the solution was. The team was able to isolate the cause of these breakdowns to a single train. It turns out that this train was going through the system, and as it passed other trains, it was causing interference and almost like killing these trains that went by. We didn't know the underlying root cause then, but what we could see was this pattern where the faults were propagating through the system at the speed of the train. And then looking at the data, we kind of finally made the hunch that maybe it's a train on the other side of the track that's propagating through the system, and then as it passes other trains, somehow it's killing them. Ultimately, eventually, it was the train engineers who figured out the underlying reason for the interference. But it's pretty cool in that case that using data, even small amounts of data, could help the investigation and point the investigation to the right path. And so that was a pretty cool project.
So I still remember this news during that time, the circle breakdown, and yeah, the investigation took a long time until suddenly a bunch of, I think, people from GovTech with you and your team suddenly figured it out. So I think that was really interesting, especially with the whole smart nation movement of Singapore. That kind of highlighted, oh, actually the technology could help in doing so many other stuffs, even like for transportation, figuring out why the root cause, even the experts, they couldn't figure out. But I think this also highlights the thing that you mentioned initially, that we need to have a multidisciplinary team in order
Yeah.
to solve a problem, because not necessarily just the experts, the one who are doing it for a long time, but also like maybe adding data, visualizations, or whatever that is, and work together to solve a common problem, which I think is pretty good journey and explanation on how tech can actually improve our lives in the future.
Yeah, I think you're spot on there. But I do want to say that it doesn't mean that, in a way, expert knowledge is not helpful and that data scientists can find things that experts can't, right? I rather like to think that it's a combination of both, that
Right.
iteration and a combination is what helps. Because any expert, by definition, knows the domain very well, but any expert also has certain assumptions or mental models of the way the world works. Typically, that mental model works because from their experience, they've seen it in 90% of the time, 95% of the time. But for these hard problems or these new problems that you've searched very hard, you exhausted the obvious things that will happen 95% of the cases. So for these unobvious cases, sometimes you need a different lens, a different way to tackle the problem. And that's why starting from a more empirical approach from data, I think sometimes helps, because sometimes I think engineers always go down a rabbit hole and then you can't solve the problem because you've gone down that path already. Sometimes you step all the way back up and then tackle the problem from a different approach. And that is what we are able to do when you have a multidisciplinary team and you have a team that respects everybody's perspective. I respect that you're a domain expert. You respect that we're data experts and we've worked with many different data problems, and then we see how to work together.
I learned about this elsewhere. There's this guy called Naveen Jain. He was explaining about how to think big, bold ideas, becoming a disruptor. So he also has this opinion that most of the disruptions that happen in the world did not come from the experts, simply because what you're saying, the assumption, the mental model is there. We have tried that before and we think it won't work. While there's a new guy coming out of the domain experts and he could come with a, maybe call it disruptive idea, and then be able to challenge and prove that actually, hey, it works. And that's where the disruptor comes actually in the world. I think like Uber or Airbnb and things like that, some of the examples of this big disruption.
And it's also
Which
about timing, though, because all these people who think in different ways, usually at around the right time that they're disrupting, there's also some shift in the way technology has evolved or the way the economics of a particular industry has evolved. And when these two kind of coincide, that's when this disruptor is no longer this annoying person, but this person with something which actually has real value, right? So it's also a combination of different factors.
So this also brings us into a good segue to the AI world. A lot of people, I'm sure many people in the world are worried. I'm an expert in my area, but now it seems, hey, this AI coming, AI and ML, and I'm scared. Will I be replaced one day with all this AI ML thing? And there's a less emphasis on the expert knowledge. What do you think about that?
I think where artificial intelligence and machine learning is that it's pretty good at relatively narrow tasks where you have a lot of data and information to go through, right? So there's a lot of interest now in language models because you've got a lot of language on the internet that you can mine and basically mine the entire internet, and machines don't get tired, software doesn't get tired. So unlike human beings, it can just work through kind of millions or billions of hours and learn from these systems. All the examples of reinforcement learning where you can see how it can play Dota and play chess are essentially that the AI is playing against each other themselves, and it can play millions of games because if you die in the game, then you can just restart, you can try again. So it's got lots of data points to learn from. So for these sorts of problems where all the data is online, all the data is captured, then AI systems can do very well. So computer vision, recognizing faces, it's all just pixels, right? It's just images and you can process this, and that's really good. Now, where AI is not so good is where you need some sort of general reasoning or that the data you require is not yet instrumented or captured. So think about all the interactions that you and I have that isn't already yet captured in Gmail or systems. I'll give you an example. So people always talk about HR analytics. I like to predict when a person is going to quit. And the truth is, look, when you quit a job, you always know it's either your boss or your colleagues, you don't get along and things like that. Now, even if I mine all the email systems, you capture some of it, but a lot of this doesn't happen in email. Maybe if you mind the Slack channels nowadays, because Slack is so easy, you'll be able to figure out that someone's unhappy. But if you don't have a lot of this latent information about the emotional connections between workers and colleagues, and that is underlying the reason why someone will quit, then you're not going to be able to build a decent HR model for who's likely to quit. I know there's a lot of coverage on it. I haven't seen any convincing examples of that. So I like to think that until we reach a time where people are installing microchips into our brains and having that ability to download whatever we're thinking, whatever we're feeling, then we should be really worried. Maybe that time is not so far away. But yeah, machine learning systems rely on data. It's not magic. In some ways, it's almost brute force. There's actually something very inelegant about machine learning. You're just brute forcing the answer. When you think of AI, what do you think? Do you think of some sort of organism, some sort of robot with consciousness? I just see a bunch of algorithms and cubes of numbers rather than any sort of consciousness and all that. So people need to figure out, people think about AI, they think of conscious beings. That's not the case. It's just algorithms at the end of the day. What you put it to do is another question.
So yeah, I mean, the day where the Terminator comes, I think still pretty far, I hope.
Yeah.
You have worked with big data and recently with this Basis AI, working on AI and ML. So what are some of the current trends that you see are growing in terms of AI and ML? Any kind of like space being hot area for AI and ML to implement? Or is there any other new technologies, new innovations that come out of the AI and ML?
Yeah, every now and then, AI has such a mythology that people are always looking for these cool new use cases that people can demonstrate. And the trick is you must have something very visual. When reinforcement learning could play Atari games, that's pretty cool. When it can play Dota, right? These are all very visual examples. But I think you need to separate what is interesting from what is useful. I talked about the example where the reinforcement learning systems can play computer games, and that's great. But in those use cases, when you make a mistake in a computer game, you die, you can regenerate yourself. But if you're using reinforcement learning, for example, to teach a robot how to put items on a shelf, can you afford a million mistakes where the robot goes crazy and then basically knocks down a shelf or kills a human being? You can't generate that kind of learning data. I think we need to be careful about thinking about what's exciting that we see in the news. So again, there was a lot of excitement over this new language model called GPT-3, which is a language-based AI model that apparently took tens of millions of computing resources to train a model. Your colleagues at GCP will be quite happy with that, right? Because they had to train a model with lots of compute. You would read an article about GPT-3, and then at the end, they tell you this article was actually written by GPT-3 itself. So in a way, it can fool human beings into thinking it's actually another human being that wrote the article. So I think this kind of Turing test examples are really red herrings, because a lot of the times these cases are always cherry picked. And it's also not always immediately clear to me how these systems can be used, because if they're so brittle and you need to cherry pick it, then it might not be that productive or useful. So I always like to say, be careful about these Turing test type examples. Always ask whether it's cherry picked. While people say, hey, this shows a lot of cool new developments into language models and the like, I like to think that the biggest challenge now is how do you make machine learning actually being more data-driven, more ubiquitous across organizations? And yes, you might need 1-point facial recognition algorithm or 1-point NLP algorithm there, but these are point solutions, right? How do I use this to make the way we operate, the way we work more data-driven, more fact-based? And I think that's the thing that I think a lot of organizations are struggling with. Just because you have a lot of tools and technologies, because you have a lot of hammers, doesn't mean you can build a house. So that's where I think the really interesting problems lie.
Yeah, I can see this as well. A lot of in the industry, people probably wants to jump the curve, saying that, oh, there are so many cool AI ML stuffs. Let's do AI ML. But whenever we want to build something, because an ML requires a lot of data, right? Like what we mentioned, but they just don't have it. I think what you mentioned is very spot on. Like being more data driven, having all these data and metrics being collected, I think is still like one of the crucial steps before you can actually successfully adopt AI and ML. I also have one thing, like you mentioned about this GPT-3. It's very interesting. Quite recently as well, I heard about someone who can produce blog posts just by having AI ML doing it. And we all know about these deep fakes where you have the videos of popular people talking about stuffs which are generated by robots or AI ML. So for us layman people, right, how do you actually spot these kind of, I don't know whether you call it fake or you want to call it arts, it's like borderline. So how can we spot this and not fall into the trap that whatever that they are producing actually can really cause a catastrophic impact? Because if it's misused, then what about it?
There are two questions here. So how do you spot these deep fakes or these generative AI models that are generating? And then the two is, how do you prevent this? How do you stop it? First of all, how do you detect it? Because being able to detect may not mean that you can stop it. But one way to test these models is the models learn from data, and they can only learn from the boundaries of the data that are given to them. So the key is throw it some left field question or something that's out of the ordinary that you wouldn't expect it to have been trained on. Whereas human beings have a much more broad, common sense, lived experience. They've seen more of the world. So if you throw them some sort of left field question, they'll be able to figure it out. But if it's an AI with these chatbots, throw it some question that it may not have seen before. But yeah, the general principle is just throw it something that might be quite rare. And then if it really messes up, then you know that it's a robot. Which is why people always ask the rude questions of chatbots, because you're trying to instinct, the intuition is the same. Throw it something it probably hasn't seen before and you can test whether it's a human. Are there more systematic ways to detect deepfakes and things like that? Yeah, I think there are. There's a lot of research into the technical details around these. At some level, this is one of these adversarial problems. It will always just keep getting better and you have better ways of detecting it. And it's like cybersecurity. And I think this is how the technology just evolved over time. I think the larger problem of how to distinguish between what's real and what's fake is a really important one. And I think there are no easy answers to it.
So how can we prevent it, which is the second question? And coming back again, I think I saw you a lot talking about responsible AI. I think this is also touching upon that, right? How do we prevent that? And how can we ensure that whenever we implement AI, it's as responsibly as possible, it's as safe and without any harm intention behind it?
I think if you are developing your own machine learning models and your own systems and you're a responsible actor, I think there are ways to do it. I mean, obviously, if there's a kind of malicious actor on the other side, then they may not want to do so. There are a couple of angles to responsible AI. The first thing is, as you're building your systems, just make sure you're able to know what goes into training the model. Are you tracking what data has been used in the model, what parameters, what model has been used, what assumptions were being made? Even things like when you're cleaning data, sometimes you have to drop rows or columns, sometimes you have to make some choices. So just being quite explicit and careful about these things, because for these aspects may affect the eventual model that's being trained. I think it's part of it, and I'm sure we'll come to this later, is just making sure you have a good engineering process. Even version control, tracking parameters, these are all just hygiene factors that software engineers have been using in other domains for a long time. The second thing is there are now a set of methods to help uncover the black box of AI. So if you talk about deep learning networks and neural networks, various ways to visualize what's going on within the neural network. It helps data scientists debug the models, but some of these can also be used to summarize the results of very complex models and to present them, to explain what are the underlying drivers. Now, explanations are a tricky topic. They always say trying to give a convincing explanation to a social scientist, to a physicist, and to a mathematician, they are not satisfied with the same level of explanation. Different demands of what's a good explanation. In the same way, it's the same. With AI, what a good explanation is to a data scientist will be different from a product manager, to a consumer, to a regulator. So this is, again, ongoing research. But this idea that you should be able to at least explain where something goes wrong so that you can try and fix it, I think is an important aspect. And increasingly, there is this idea of fairness. AI algorithms will take any feature you feed to them and use it to try and predict more accurately. So if you feed to it gender or race, it will try and use these features to try and make a personalized recommendation. But again, there is a whole realm of ethics, and morally, human beings feel that some of these features shouldn't be used to distinguish and to make decisions. And so this is a human ethical constraint that we need to put on the way we develop these models. Now, there are ways to quantify the impact. So with any machine learning model, you have a certain accuracy or error rate that you will generate. No model is completely 100% correct. Now, the question is the model making errors on women versus men differently? And if it is, you need to have visibility of this. Just like any form of monitoring that you have in any software system, you need to be able to monitor the algorithmic performance of your models and whether they're treating men and women in the same way. So our approach is really, how do we give better visibility into these systems? How do we give visibility into the explainability metrics, into the fairness metrics? Also part of the engineering process to build these models. And there, I think, gives you the foundations for building responsible AI systems and responsible software, because you want to be able to know when things go wrong. One observation that I think might be interesting for people to be aware of is typically you design software to fail spectacularly. When things go wrong, you want it to fail spectacularly so it doesn't do more harm. Problem with learning systems and AI systems is that the algorithms can learn the wrong thing and they can continue to perform fine. So the microservice will still be up. There'll be 99.9% available, but it will give you a really bad prediction 99.9% of the time. So you have to think about different ways and SLAs when thinking about machine learning systems from traditional software.
I'm quite curious about this, how you do the explainability, the fairness thing, because all I thought is that AI ML is a black box. You train it over a long period of time, you throw it a bunch of data, and it just comes with an algorithm out of the box. But how can you actually come up with all these explanation, maybe metrics to quantify, oh, these are the actual features that the algorithm puts a lot of emphasis on? How do you do that actually? Maybe going a bit technical here.
What I suggest, and maybe you can put a link to this, you have a look at TensorFlow Playground. TensorFlow Playground allows you to train a neural network in your browser. What's really cool is that as you're training the algorithm, it gives you an insight into what is going on in the individual neurons within the neural network. So a neural network is in some ways organized based on how your brain is supposed to work and how neurons in the brain works. What the visualization here is showing is actually how each of the neurons is thinking. And you see that in the early layers of the neural network, the thinking is quite simplistic. So in this neuron, any dot that's above a certain straight line boundary, it considers to be orange. It's trying to classify between orange and blue dots. Anything above a certain threshold, it's orange and the other one is blue. And there's a more linear way of thinking. But as you go from layer to layer in the neural network, what is essentially the thinking almost is a lot more sophisticated. It's able to draw boundaries that are less linear and more nuanced based on the data. So this, to some extent, gives you some intuition, and there are techniques and methods to allow data scientists to inspect what's going on behind these very complex algorithms. And so that gives you some intuition into how these things can work. Those who are curious, you can look into research methods like Shadley values or Lime. So Lime will be able to say, hey, I've predicted that this image is a dog, for example, but you can point to the pixels in the image that led the algorithm to make that prediction. So it does give you some sort of link or explanation of why that particular prediction was being made.
So coming to the actual implementation in the industry, obviously everyone wants to do this AI ML now. I think we touch a bit. The first problem is about the data. But what are the challenges that you see in terms of in the industry? How people want to adopt AI, but there are so many hurdles that they need to go through. Maybe you can share some of the big challenges there.
Yeah, I think the first thing is there are many ways that people use AI systems. So sometimes they just consume an API. So if cloud provider has already translation service, facial recognition service, and they train this model off all the data on the internet, then you just call it API. And then you send the API an image that tells you what's in the image. And in these sorts of situations, I think it's quite straightforward. But then the use cases tend to be very generic. So if I have a very generic use case, object detection, as a cat, as a dog, then these things will probably work well. But if I'm in a manufacturing context and I want to distinguish between various manufacturing defects, it's unlikely that all that information is on the internet and that Google has mined all this data, it's on Google Photos. That object detection algorithm in a manufacturing context will probably not be good enough. So in these situations, if you're a manufacturing company, then you need your own data to train the models on. And then the question is, have they been collecting this data? Have they been storing it, persisting it? Have they captured enough labels of what good or bad examples are in order to train the AI ML systems? So I think the first thing is just getting their data in place. The second bottleneck I actually see is having the conversation between the business, the data science teams, and the technology teams about what problems are you trying to solve? What can AI do with the data that you have? And this is a very iterative process. Sometimes business comes with a lot of problems that are like science fiction. So some financial companies come to me and say, hey, can you help me predict how the stocks in the stock market is going to move? Use AI to do that. Then I said, if I can do that, I won't be spending time talking to you. I'll be I'll be trading for your trader already, right? It's such a good problem. So again, some science fiction, others, they throw a lot of resources solving solvable problems, but they are research level problems. And I'm like, hey, do you really need to be solving this problem? Can we simplify the problem? I think there's a lot of that back and forth where the business side will want a perfect solution, where I'm saying, you know what, you have a process. Maybe 80% of the process AI can handle. The last 20%, let the human being solve that last 20%. But you say the human being 80% of the time, rather than trying to solve the entire process. So a lot of that, how do you find the right solution that meets what business needs, that can leverage the data you have, versus something that can be leveraged off either transfer learning or open source, where you don't need to kind of reinvent everything from scratch. This discussion, this translation and ideation and solution is the part that I see the greatest bottleneck. Business people who understand some intuition about how AI works, that it's not magic, that you're learning from the data. You need the right data scientists who appreciate what the business needs, but understand deeply what the state of the art is. And then also people who understand what data is available. Because a lot of things are theoretically possible, but if you haven't been collecting the right data, then that's not possible.
I can totally understand like scoping the problem itself. So obviously we are all living in the science fiction, right? We've seen the Matrix, the Minority Reports and things like that. Yeah, sometimes people tend to be influenced by those, but scoping the problem, I think is still a challenge. The other thing I probably see is that whenever you try to explain this to the stakeholders, they are not necessarily the most technical people. Sometimes there are a lot of unknowns, uncertainties compared to building software. You kind of know what will be the first beginning and the end output. Once you achieve all the output, yes, okay, take 100%. This is your payment because you deliver the solution. But what about AI ML? I can see that sometimes because it needs a lot of iterative process, a lot of probably analysis, sometimes the result just totally bomb, right? It's very disappointing. So how do you actually manage expectations, maybe from your experience with BasisAI as well? How do you manage this?
So you need to think about the validation of the algorithm first before you try and productionize it. So a lot of people try and build the end software first or build the kind of analytics platform without thinking about the use case and validating the business impact. So what we would do is say, okay, you've got a problem you want to solve. Maybe you want to increase your conversion rate or click-through rate on your e-commerce platform. We'll build you a personalization engine to do that. Let's try it out. So let's do a couple of sprints, take a month, maybe 3 months, build an MVP of the model. I validate the accuracy of the model. For each case that come in, what was your old conversion rate? Can we back test it? Can we A/B test it? And then convince the user on a small scale, hey, this works. And then very quickly from there, if they're convinced, you then take that and say, okay, I'll guarantee that this accuracy is the baseline, the benchmark. We continue to assure you of that, but let's help you productionize that. And we help you maintain and productionize that later on. So you have to start almost very close to the business and validating the accuracy of the model. And again, how the accuracy translates to a business impact. So you can talk about precision recall, curve, all the various metrics, but that doesn't mean anything to business. It's about, okay, taking this, let's run a business simulation. Let's make certain assumptions about your business. And based on 80%, this is the kind of cost savings we can generate for you. And you break it down for them, then you have the conversation. So again, you're absolutely right. Traditional software systems is more functional. Is the user experience pleasant? You can test the functionality and whether that works with very different conversation.
So you keep mentioning about this productionizing AI ML. Could it be one of the other challenge when you want to adopt AI ML? Maybe you can tell the audience here who are not familiar with this problem.
I think ultimately it's a multidisciplinary problem because data science are very good at building algorithms, statistical knowledge, understanding. They're the scientists by training, but they're not engineers. They don't have to keep the lights on. They don't understand containerization, the Kubernetes. They don't understand networking, cloud infrastructure, site reliability. These things are very foreign to them. And the truth is a lot of data scientists are very frustrated because they build this model and they want to put it into the wall, they want to test it. And then it almost has to be thrown over the wall, the engineering team or infrastructure team. And these guys haven't been trained to understand ML systems, how they work, how they need to be retrained, how you need to monitor them in different ways. It's not just throughput and latency, it's also algorithmic accuracy, it's also fairness. And so a lot of things get lost in translation. And as I mentioned, I think part of it is also organizational. So back in 10 years ago, when data science was started, they put data science with IT or technology. And that was a mistake because data science needs to sit very close to business. So they move data scientists now closer to the business so they understand the use case and what the data means is very important. And for that, you need to sit close to business. But now that you sit close to business, once they build the model and they want to productionize it, they need to go back to the IT teams, the technology teams. And then there's another barrier to go back to those teams. So this is what we've seen at bottleneck. I've had experiences where I've got a great model, my data science trained a model, feel very happy with it. Takes another 6 to 9 months for an enterprise to work with a vendor, hand over the model, get them to productionize it, maintain it. Very frustrating process. And then when something breaks, debug what's going on, it's a real pain. So I think this scalability, productionization, I think is a challenge. Now, you can stand up a whole machine learning engineering team just to do this for you, but we've tried to develop some technology to help the data scientists be more productive. So help the data science abstract away Kubernetes concepts. Everything is containerized to them. They don't really need to worry about those, but they can easily get to a microservice or an API that they can run. Now, obviously, there are trade-offs. When you do this, you obviously can't optimize at a very low level, but for most of the use cases, maybe that's sufficient.
Is it like probably one way to solve this problem is to make it more like self-service kind of thing for the data scientists?
Yeah, you're right. It's a lot about self-service, but also about giving the right flexibility when it's needed and the right positive constraints when it's needed. So for example, data scientists use many different open source frameworks, TensorFlow, Scikit-learn, PyTorch, and we want to be quite agnostic about that. So we want to leave it to them to figure out what tools they want to use. At the same time, data scientists, they don't want to have to wrangle with, like I mentioned, Kubernetes and Spark. All they want to know is what kind of resources they need. So abstract away the things that they don't need to worry about and then allow them full flexibility on the stuff that really allows them to get their work done. The other thing is obviously data scientists like working in notebooks. So it's very interactive, but that's not great for productionizing something because it's very hard to version control notebook. And so sometimes you have to insist with positive constraints. He says you need to check everything into a Git repository before you productionize. So sometimes it's putting in some discomfort, but for good reasons, because the context on experimentation is very different from when you're in productionize. So a lot of our conversations internally are really around what the data scientist mental model is and what the engineer's mental model is. And we realize that they're very different. But sometimes you need to nudge certain groups to think in the way that engineers think, because I think software engineering has a much longer history of good engineering process, whereas data science is a much newer domain and discipline.
So I also think that, like what you mentioned, data science is still in the early days, maybe, if I can put it that way. And also, I think if let's say you want to build a very sophisticated AI and ML system where probably you can use the real-time data coming in, training by itself, and update the model on the fly as well, and provides the API for people to use that in real time. So I think there are a lot of things that needs to be done, like how to get the data in real time, how to store it, maybe clean it, wrangle it, and also feed it into the training model, use the elastic infrastructure. I can see this can go way complicated. Would it be logical then in the future that ML engineer is just one part of the team? We call it feature team or whatever. These days, people adopt agile, so they like to build a feature team kind of thing. Would that be a day where ML engineer would become just one member in the team?
I can see a future where that's the case. Again, in a world where we just have a much even greater ability to collect information and data when IoT becomes even more ubiquitous. Yeah, so I can see the ability to handle data, to process it, make sense of it, I think will always be there. The interesting thing about maybe not so much the ML engineer, but a data scientist role is that a data scientist is often the bridge between the real world and the data. A database admin doesn't really need to understand what the data means. Obviously, it has to be valid, but the meaning of data isn't important. Whereas the data scientist has to work with the business to understand what the data in a data store database means and how that can be mapped to the business need. And that's very contextual, and that's going to differ every single time. And so the mindset of a data scientist is always about being a bit more creative, a bit more understanding the context, and then building the right models that optimize for what the business wants. So that part is something that you can automate or industrialize that easily. Now, the engineering parts, the ML ops components, the right monitoring, the right kind of pipelines, the right building for scale, the right kind of ingestion for real-time streaming, those things you can engineer. And those things are much more within the realm of engineering. To your point, when you're thinking about what roles are going to be embedded in every team, it's also important to think about what roles are really building your core engine and platforms that can be reproduced and replicable and scalable. And that's going to be a central team that maintains that infrastructure almost. And what stuff tends to require some level of contextualization. And then every product team is going to need that role. So I think every product team is likely to need a data scientist, probably an ML engineer, right? But depending on how technology evolves, maybe that ML engineer is something that's kind of part of the core infrastructure team rather than something that every product team has. We'll see how technology in the industry evolves.
I have a related question to that these days, especially because AI ML is so hot. Many people would love to be a data scientist or do anything related to ML. So my first question will be, is it possible for someone who don't have any background in mathematics or algorithms or even engineering to be, how should I say, a good person in AI ML? And second thing is that, is it also wise to just go with data science? I've heard mixed opinions about this. We don't probably need a lot of data scientists. We need more people who can productionize it. So what's your thought behind all this?
Unfortunately, with any new disciplines, the titles are often confusing or they mean different things. So they're overloaded, either that or not specific enough. My experience has been that a lot of data scientists have a stronger scientific background. They understand statistics, algorithms. A lot of them aren't necessarily computer scientists. Some of them are, but they come from other disciplines like bioinformatics. There are a lot of good data scientists from bioinformatics, some from econometrics, some from other engineering disciplines. That, I think, is one role that I think of, data scientists. And in that realm, the data scientist needs to understand the domain. So the skill sets and the aptitude, it's more the inclination and aptitude is what does the business want? How does the real world work? How am I gathering this data? How do I interpret this data? And how do I build a model that solves what business needs? They're not thinking about scaling. They're not thinking about how do I build this once and then generalize and scale it. That aptitude and the inclination of the data scientist is, I think, one skill set. That's very important because that often is a translational role that I feel is missing. So a data scientist that can code, can write models, can build models, but can talk to the business, super important ingredient in any team that wants to be data driven. The second thing is obviously you need the ML engineering team when I need to productionize things. And this is things like how do I set up Airflow, Spark clusters? How do I wrangle with these Kubernetes? And again, that requires again your infrastructure teams to get on board as well. These guys have completely different training and background and inclination. Their instincts are completely different. I feel like tech is one of those areas where you have to keep learning. So it's about finding what suits your own inclination and aptitude more than the knowledge. Because if you're motivated and you're smart, you'll pick it up. But again, I think ML engineers are less inclined to think about the context or the business use case. They're trying to build systems that can scale, that are resilient, and are fault tolerant. And so it's a very different kind of mindset almost.
So I saw one of your recent talk. It's about having hyper-personalized AI experience. Maybe can you share with us what do you mean by that? Is it like one day I could have someone like Jarvis for people who watch the Avengers movie, like Jarvis, helping me, assisting me in anything about me and myself, rather than having more a generic kind of AI ML model for business and for whatever problems in the world. But could we one day have something like Jarvis for us?
There are many different connotations when you take stuff from the movies. So you've got to be careful and quite precise about what we mean there. But yeah, the whole idea with machine learning is it allows greater personalization, which means tailoring whatever recommendation. You have so much choice. How do I filter down the choice? So it's a search problem to some extent. How do I filter down the choice and show you the stuff that's most relevant? And because of what you've seen on e-commerce, on Netflix, I think with more data or understanding about people's preferences and choices, then you can narrow down that field and give people what they want more quickly. There was an interview or talk that I gave that said there's a danger with this, obviously. Because if your choice is predicated on what you used to click on or what you used to want, then I'm just feeding you more of the same. And if you think about human beings as more exploratory, as being open to new ideas and new inspirations and new things, then there's a certain path dependency. You're locking people into showing them more of what they want and not giving them opportunity to learn about new things. Right now, somebody who builds more sophisticated recommendation engines will say there are ways to surprise users. And of course, that's true. But I think at a high level, you need to think about, are you in a situation where people know exactly what they want? You're optimizing to show them stuff and get them addicted and hyper engaged. Is that a good thing? In some cases it is. In other cases, maybe you don't want to do that because engagement sounds like a good thing, but addiction sounds like less of a good thing. And it really depends on the context. I mean, a lot of education, if you think about when you were going to school and all that, there were lots of things you didn't like to learn or you didn't like to experience. But because you were forced to, you're like, hey, actually, after a bit of that, you realize, hey, this is really cool and really expands my knowledge. With all this concern over people being in your own kind of bubbles and echo chambers, can hyper-personalization exacerbate that? Because you only get seen stuff that you want to see, and then suddenly you think, oh, everybody's you. And then when someone else says something different, you get outraged because how can you even think that? Everybody knows that this is the case, and that's fake news. The other side is seeing all the things that they think is true, and anything that they see that's new is fake news. And that's a very kind of dangerous world to be in.
Yeah, so I can see this. We all know this quadrant known unknown thing, right? Could it be possible that with all this hyper personalized experience, you will be having more unknowns because you have kept feeding all this? The first choice that you choose will be the path that you're going into without you actually knowing there are so many other interesting stuff out there. Okay, I think it's a very exciting talk. I think due to the time constraint, I have to ask my last question as
Okay.
usual for all my guests. Would you be able to share your 3 technical leadership wisdom for all of us?
I'm not sure I have any kind of wisdom, but I'll share 3 ideas and hopefully your audience can see if this is useful to them. I think one thing that I found working with a lot of data scientists and engineers is when you're working with data and software, communication is super important because it's so abstract, because it's all in your head, and because it's important to collaborate to be effective in larger teams. Being able to share what's in your head with your team members is super important, right? If there's a text every time there's some form of IO, then it's going to be a very unproductive team. So again, I always ask, especially the engineers and data scientists, think hard about how you make yourself effective in communication. And there are many different ways. Some people talk better. Other people like to write docs, synchronous docs where everyone chips in. Other people have very good ways of commenting code. Some data scientists write very nice Jupyter notebooks. It's very nicely organized and visualized. Other guys do really good technical talks, sharing to their team. And others do very nice dashboards where you can interact with the data and understand what's going on. The point is, there are many different ways to communicate. Some people say, oh, I don't like to talk, so I'm not a good communicator. That's not true. Everyone has a different flavor of how you communicate. But investing in how you communicate is particularly important, I think, in the world of data and software because everything's so abstract. If you're building a bridge, you just point and say, there. But it's a bit harder. Not everyone can see a kind of physical elephant or the physical kind of structure. So communication is one thing that I emphasize quite a bit. The second thing I would really think about is making sure you're always learning. I think that's the reality of being in technology and software. And you need this innate hunger to learn. If learning is tiring for you, then go into a different job where technology only evolves only once every 10 years because it's tough, right? You're always having to keep up. You're always having to learn something new. I always suggest to the people I work with, look for adjacent areas. So you're focusing on one area, look for something adjacent to that. It's kind of related to what you do, maybe a different angle and pick that up. And then it's kind of a search through the different technology space. Over time, you find yourself in a very different world, but there's some loose connection between all of them. For me, I used to be very interested in university in typography because I used to read books and I noticed the typeface is kind of very different. And then randomly, I thought data visualization is like typography, but for data. Then I got very interested in data visualization. And then I got very interested in, what are the different technologies you can use to visualize data? So with my team, we were looking at D3.js and then obviously various tools like WebGL. You learn different ideas from one starting point, typography to visualization to front-end technology, and then you go from there. And sometimes you end up in very strange places. But that, I think, is what makes technology interesting. The third point I would make is I think a lot of engineers are very happy talking to machines. Sometimes talking to machines is very different talking to other human beings because machines tend to be a lot more explicit. There's less hidden information, or at least you can probe it to find out. With human beings, sometimes if you probe, there's always a filter and there's always this issue of emotions. So in my experience working in all sorts of teams, whether teams are functional or dysfunctional really depends on emotional reasons. It's emotional relationships, it's anger, it's frustration, it's ego, it's jealousy. This is why if we were all robots, life would be perfect in terms of human teams. So I would say to even engineers, and if you're going on a technical career, make sure you think about communicating not with machines, but invest in communicating with your teammates. And a lot of it is forming that emotional connection, that trust, working through some of these emotional responses that people have, that you have, and being aware of that. It sounds very touchy-feely and very non-technical, but if you believe that individuals can't scale themselves and you need to work well in teams, then you need to think of all different sorts of solutions to make teams effective. Some of that is communication, my first point. Some of that is making sure you have multidisciplinary skills, my second point. But the third thing is having good relationships, and that's a more emotional angle to it that you shouldn't shy away from. This is my advice.
Right. Wow. I think it's a very good thing, especially for all engineers out there. Don't talk to the machines, talk to the human as well.
You need to talk to both.
So, Feng-Yuan, thank you so much for your time. I really enjoyed this conversation, especially for me. I'm not a very super sophisticated AI ML expert, so I learned a lot from your experience and your sharing today. And I hope all the listeners out there can also learn about AI and ML and whether some of the things that you would want to pursue for your career as well. Thanks again, Feng-Yuan. Is there any place for people to find you online?
I try and keep a kind of low profile online, but you can look for BasisAI, I think, on Instagram and on LinkedIn and on Twitter as well. So do follow us and keep track of what BasisAI is doing. And yeah, I'll be happy to follow up. If people want to reach out, my email address is Feng-Yuan, Fengyuan at basis-ai.com. So if you want to reach out and have a chat, happy to do that.
Thanks for your time, Feng-Yuan. I hope to see you again in the future episode.
Thanks, Henry.
Thank you for listening to this episode and for staying right till the end. If you highly enjoyed, please share it with your friends and colleagues who you think would also benefit from listening to this episode. And if you're new to the podcast, make sure to subscribe and leave me your valuable review and feedback. It really helps me a lot in order to grow this podcast better. You can also find the full show notes of this conversation on the episode page at techleadjournal.dev website, including the full transcript, interesting quotes and links to the resources and mentions from the conversation. And lastly, make sure to subscribe to the show's mailing list on techleadjournal.dev to get notified for any future episodes. Stay tuned for the next Tech Lead Journal episode, and until then, goodbye.